Welcome to Math 104, Chapter 1.3, where we talk about linear functions. So now that we know what a function is, now we're going to put on the spin with where we're talking about lines. So a linear function is a function that can be written in the form f of x is equal to ax plus b, where a and b are constants. Now, that being said, we can also see this as another formula, one that you, I think, are a little bit more familiar with, mx plus b. Now, f of x is a very fancy way to say y. So we can say y equals mx plus b if you prefer, where m is considered what? M is your slope, and b is your y-intercept. Now, I'm sure you guys are familiar with graphing lines, so we will just do a very quick reminder of how to do that. Now, what does it mean? Ooh, what does it mean to be linear? A linear means we are working with straight lines. So let's take a look at what some of these values that straight lines would actually look like. So linear, while we can have two variables, we want to make sure that to be linear, we only have your x value, right? We can have any sort of coefficient, but your degree on your x is always equal to 1. So here's your second second variable. We can put on any sort of spin. We can say 5, 15, whatever number that comes next. But for right now, there can only be two variables that we're working with. Again, big takeaway is that your degree on your x is equal to 1. We could also rewrite this so that your variables are on the same side. Perhaps we subtract the 2x to the other side. The only difference is that your variables are now together. That is still a linear formula. So your degree has not changed. So if you notice that your degree of your x is now different, that is not okay. It always has to be equal to 1. Now, one other thing. If you have any variable, let's say we have y is equal to 1 over 2x plus 3, anything like that. If your x is now located in the denominator here, that is not linear. So your x value has to be in your numerator. It can still be multiplied to a fraction, but yours cannot be in the denominator, just like it cannot have any degree other than 1. So x squared plus x plus 4 would not be considered linear. All right, so that's what it means to be linear for right now. So if we are to continue on, right, linear, right, a straight line will have intercepts. And intercepts are points on the graph where the line touches or crosses the axis. So you can either have one that touches the y-axis, which would be your y-intercept, or your x-axis for your x-intercept. So your x-intercepts are points that cross the x-axis. These can also be called solutions, roots, or zeros. So if you're using a TI 83 or 84, when you hit your second trace button, it'll say 0. That's what it means when you want to be looking for your x-intercept. This is always when your x is some number, but your y value is always 0. Now, the opposite is true for your y-intercepts. Y-intercepts are those that cross the y-axis. In this case, It's when your 0 is your x value and your y value is some number. So if I were to draw a really quick example, maybe something like that. To the best of my ability, that is my graph. Can you label your x and y intercept? Well, your y-intercept is somewhere over here, 0, 5, and your x-intercept is 6, 0. So again, each trading off where you're having zeros. So let's take a look at this one. Is this equation linear? Yes, it is linear. It is okay if your variables are on the same side and your x value, your x degree is 1, so that is even better. So if we're trying to find your intercepts of your given equation, we can certainly do this graphically, which I'll show you here in a moment, but let's use the idea where we'd figured out what your intercepts can do for us. So if we're trying to figure out your x-intercept, keep in mind your x-intercept is when x is a number and y is equal to 0. So if we know that y is equal to 0 and we have your equation, 3y plus 4 is equal to 12, how is that helpful? Where is that connection? Well, if we know y is equal to 0 and we have a y here, we're just going to substitute that right in. 3 times 0 plus 4, 4x is equal to 12. Well, then you just have 4x is equal to 12. Divide 4 by both sides, and x is now equal to 3. So we have the intercept 3, 0. Now let's try it again for your y-intercept. So try it out yourself, pause the video, figure out your y-intercept. Your y-intercept is where your x value is 0 and your y value is some number. So we're now going to do the exact opposite. So we have 3y plus 4x is equal to 12, where we replace your x value with a 0. So we have 3y is equal to 12, divide both sides by 3, and you get y is equal to 4. So your y-intercept is 0, 4. So using that trade-off is pretty valuable. Now we can also put this into your graphing calculator just as you see it. This would only go for Desmos. For your TI 83s or 84s, you would have to then subtract the 4x to the other side and divide by 3 to get it into the form of y equals. That is not the case for Desmos. Desmos, we just punch in and go. 3y plus 4x is equal to 12. So it'll pull up with your x and your y intercept. Now let's talk about the slope of your line. So your y-intercept, we've talked about a second ago. These are going to be your b on your equation. So if this is your b from your equation above, we are now going to be looking at your slope, m. So your slope of a line, m, y equals mx plus b, we're looking at your m value here, has an equation. This equation says m is equal to y2 minus y1 over x2 minus x1. Now, what is y2 minus y1, x2 minus x1? Well, these are points on your graph. points on your line. Y2, nope, points coming from your coordinates. We have x1 and y1 and x2 and y2. Now, all you have to do is then sub it in once you have your equation. Now, better yet, your slope is also called what? What do they kind of abbreviate it to? Some of you might say the change in y over the change in x. I hear that one quite often. I'm just going to move this part over. Others say rise over run. So rise being you're increasing or decreasing on your y values, and your run being you're increasing or decreasing across your x values. Now, slope, as we just talked about, can be found by using any 2 points on your line. So as long as you have 2 points, you can figure out the slope of your line. Now, your slope is also referred to as the constant. Oops, 2 points. Constant rate of change. Now, that is only for a line. So the constant part is the slope of a line. If it's just the average rate of change, they are asking for a slope. However, it's constantly changing, like it's not at a constant rate. So you might hear average rate of change, but that is not going to be for lines. Now, before we get to an example with your slope, let's take a look at some orientations given your slope. So can you do the following? Draw a positive, negative, horizontal, and vertical line. So positive, it doesn't matter where you put it. I'm just going to draw a positive line. Negative line. Horizontal. And vertical. All right, so if I said, hey, of these, which one has a positive slope? What would you tell me? Well, positive lines have positive slopes. So this one having a positive slope, m is greater than 0 means positive. It just means we are increasing in your slope. Let's find a good stopping place. So your slope is rising, or your graph is rising, right? Rise over run. Whereas your negative line is the opposite. Your slope is less than 0. We are falling. We are a negative slope. So any sort of negative line. We are decreasing. So we have rise over run, and it is a little misleading when it says rise because this graph is falling. This line is falling. It's just a change in your x values. So this will have a positive slope. This will have a negative slope. Now, so far, are we equal to 0? Now, this one is greater than 0. This one is less than 0. So one of these has to be equal to 0. Now, of these, one is equal to 0. The other one is undefined. Now, keep in mind, if your slope, right, is actually, before I say that, how did I say it in class? So if we have on this one, m is equal to 0, our line y equals mx plus b, right? If we know m is equal to 0 here, so if m is 0, that means x is multiplied by 0, so we have y is equal to b. And what do we know about b? Well, b is your y-intercept. Now, of these two graphs, which one has a y-intercept? Well, your y-intercept is not located on that graph. However, it is located on here. It just means for all of your values, y is going to be equal to this value. In our case, y is equal to 3. So the line of this graph would be y equals 3 for the whole thing. Your x values are changing. Your y value is not. So -2, 3, -4, 3, -7, 3. Your y value is constant at 3. So if this slope is equal to 0, so horizontal lines have a 0 slope, that means this one is undefined. Oh, come on. Now, the reason why it's undefined is from your equation of slope. We said y is equal to y2 minus y1, x2 minus x1, right? The change in y over the change in x. Well, is there any change in x? No, there's no change in x, which means we have 0, but is 0 allowed to be in the denominator? Absolutely not, which makes it undefined. So vertical lines have an undefined slope. We could have also done the same for the other side. Y equals y2 minus y1, x2 minus x1. We said no change in your y values, so your 0 is up here, which means your slope is 0. So that's okay if it's in your numerator, not okay if it's in your denominator. And we've done all of these. We've paired all of your drawings above with your following. So now let's try it with example 2. Find the slope and y-intercept of a line. So pause the video, see if you can identify your slope and your y-intercept. Well, your slope on this first one is easy to find because it's directly attached to your variable. So your slope in this case is 7, and your y-intercept, b, is equal to -12. Now, is this line going to be increasing or decreasing? Well, this should be an increasing line because your slope is positive. Now, on this next one, it doesn't exactly give it to us. So instead, we might want to be able to transform it into a line that looks kind of like this one, because notice how easy that was to start. So let's transform it into y equals mx plus b. So that means subtract 2x to the other side. -3y is equal to -2x plus 12, and divide all by -3. Y is equal to 2 over 3x minus 4. Now with that, can we figure out your slope and your y-intercept? Your slope here is 2/3, and your y-intercept, your b, is -4. So in case you are given it like this and you don't feel like putting it into your calculator, just put it into this form so that it's pretty easy to get. Again, you can try this graphically. It's up to you. So now let's calculate the slope of a line passing through these 2 points. So given the equation of slope, which we saw a while ago, can we put it into, or can we find your slope? So pause the video, see what you can come up with. So let's try your equation. M is equal to y2 minus y1 over x2 minus x1. Now, students at times end up mixing and matching their points. We want to make sure that this y2 above goes with the x2 below, and same thing with the y1 above to the x1 below. Now, in order to do that, I just suggest really quick label the first point x1, y1, and the second x2, y2. It really doesn't matter the order. The first one could be the 2's, the last ones could be the 1's. Again, doesn't matter. But let's put that into your equation. So it's just a plug and go. We have -4 minus 2 over 5 minus parentheses a -3. So this minus sign here is this minus sign here. You have a -3, which is then your -3. So be super careful. Use your parentheses as best as possible. So then we have -4 minus 2 for -6, 5. And this is a negative times a negative, which makes it positive. So 5 plus 3 is equal to 8. Now I will show you a cool feature for those that are using your graphing calculators for TI-84. We can do a reduced fraction. So let's say we didn't know how to reduce 6/8, and it did not want us to put it into a decimal. So what we're going to do is hit the math button over on the left-hand side, right underneath the green alpha button. And we're gonna select this first option where it says frac. We want to change your answer into a reduced fraction, which will come out to -3/4. Now, how we can reduce by hand is what do 6 and 8 have in common as far as their factors or their multiples? Well, 6 is made up of 2 times 3, and 8 is made up as 2 times 4. So they both have a 2 in common, which we can slash out. And whatever is left over is a part of your fraction, -3/4. So now let's calculate the slope of a line passing through the points for 0 and 7, 2. Now let's sketch the graph. So I'm going to show you after this one how to do it on your Desmos graphing calculator, where it actually is going to give you the equation. Well, nearly give you the equation. So we can graph these points for 0 right here and 7, 2. Right there. Okay. So, okay, so this is our line as best as I could draw it. Now, if we're trying to calculate the slope of a line, right, given these values, your slope is just your rise over your run. So in order to go from point to point, I might zoom in here for a second. We want to go up 2. So we went up 2, so this is really a +2. And then we want to go all the way over 1, 2, 3 until we get to your point. So your slope here is 2/3, rise over run. So in order to get to your next point, perhaps I did not draw this ugly looking line. So we can just get to your next point. We go up 2, 1, 2, and over 3, 1, 2, 3 to your next point here. Or if you wanted to go in the opposite direction, we're just going to go down 2 and over 3, 1, 2, 3 to your next point. And we can keep going as much as we want. Let me erase that line. So if that is your point, we can also find your y-intercept through it as well. But our big takeaway was figuring out, given 2 points and putting it onto your graph, can you determine your slope? Now let's have Desmos do the work for us. Oh, there we go. So if we have the same idea here on your Desmos, let's click that plus button and notice that it has a whole bunch of different options. We're going to click table. Now on your table, we're going to put in your point for 0 and notice that it pops up over on the right hand side. And again, we're going to do 7 and 2 and another point. Now in order to get these values to connect, we are going to hold down that red dotted figure, and we are going to put a line through it. From there, you can notice that it is now easy to see the next few values. So going up 2 and then over 1, 2, 3 to get to your point. Now I am curious to see if I hit the enter button, we can then put in your other point where I think we had said your next point was what? This would be 1, -2. And if we did it one more time, let's try it one more time. Down 2, over 3, 1, 2, 3. We should get one more point here, being -2 and a -4. So let's do that. Oh, I already forgot our values. 1, -2, 1, and a -2. We said -2 and a -4. So as long as we have your straight line, we can also determine your y-intercept here as well. Let's see if we can click. No, but we can kind of zoom in and figure out your y-intercept from here as well. Oh, that's really trippy. That's very cool. I haven't done that on our on the iPad yet. So you can always calculate your slope given 2 points on here in case you needed an extra way to do it. Now let's take a look at a more applied question. This says the amount of money to be paid on the loan, not load, loan of $60,000 with $16,500 interest is the equation that you're seeing over here, where X is the number of monthly payments. Graph on your graphing calculator and sketch below. So then what are you seeing? Find the slope of the equation. What is your x-intercept? What's your y-intercept? And so forth. So let's try and do that. So we have, oops, I'm going to do this other one, Desmos. Okay, so we have y equals 6,500 minus 1275 and oops, 1275x. Now, if you're not understanding where they're getting the 16,500 with the interest and then pairing it with the 60,000, notice that together those will make your y-intercept. I should have made that a little bit clearer. So we have this equation, and notice that if you're not seeing it here, that just means your window isn't all that great. So if you're taking a look at your y-intercept, right, that's a very, very big value. That's $76,000, right? 76,000 values. So we're going to have to change your y to a much higher value. So let's change it to maybe 80,000. Notice by changing that, it gives you that line automatically. Now, do you consider this a good window? No, it is not so good. We don't see our x-intercept. We don't see too many of your x values. We might consider, because there's such a huge gap between this -6 and 80,000, we might want to consider changing this to maybe -10,000 so that we can get a little better gauge on what we're doing in space. Now, as far as your negative x values go, we are talking about an amount of dollar payments over a monthly period. So we don't need to be super negative because X is in months or X is a time value. Instead though, notice that we're not seeing your X values to the right-hand side, which means we need to change your X values to be right, your maximum. So let's get a little larger than the 17. We definitely want to see it connect with the X-axis. So perhaps if we want to try 20 to start, That's not going to cut it. So let's get a little larger. Let's say 50. 50 is looking a little bit better. And again, I'm not just using my finger because I want to simulate what we might be doing if you're doing it on a graphing calculator. So let's get a little bit larger. Let's say maybe 70 is key. So here you can see clearly we are passing through your x-axis. You can also see your y-axis. Things are labeled nicely. You can also try to look at your steps. Perhaps you want to go up by 5s, or you can continue with the 1s. This one is going up. Yeah, actually your x values looks like it's going up by 5s or so. Okay, so now that we have this, we can sketch this onto your graphs, and now it says find the slope of the equation. Well, actually, our equation is giving it in y equals mx plus b form. So if we were to switch your values around, negative 1275x plus 76500, right? Find your slope now. Well, your slope is this value here. Now, what does that mean in the context of your problem? So this is part E. It says how much does, or I can't speak today. How does the amount owed on your loan change as the number of months increases? Right? Well, that is just another way to say, hey, what are your values increasing or decreasing by? And if I were to just finish out this picture down to here, let's see if I connect these two values. This being your 60, 0, and your 076 500, right? It is just saying by how much are these values changing, right? Well, we can certainly figure out what your slope is, or we're just given your slope. So this means for each month, the payment is, and ours can either be increasing or decreasing depending on the orientation of your slope. Because ours is a decreasing amount, we are falling on your graph. So we are saying is decreasing by our slope to $1,275 each month. So our next segment would be $1,200 or so less than our very next point. Now let's take a look at your x-intercept and what does that mean? Keep in mind, we're talking about monthly payments. So your x value here is a monthly value. So come up with a good sentence on how that might work for us. Well, we could say it takes 60 months to pay off the loan. Now, can you do the same thing for your y-intercept? Again, your x value is monthly, and your y value is a dollar amount, the loan amount. So we can say something like, initially, we have to pay $76,500 on this loan. So something along those lines. So again, use your graphing calculator as best as you can to figure out your intercepts and just bring meaning to your intercepts.